Hello students, in this video I am going to explain the named reactions in organic chemistry. This is a very useful video for the prepare for a board examination. In board examination at least 2 named reactions will be asked for 3 marks. So altogether there are about 20 named reactions. If you practice these 20 named reactions you will get 3 marks. And of course these named reactions may be useful in other questions like conversions, etc. Please subscribe to my channel, like, share and comment my videos.
Let us discuss the named reactions in organic chemistry in an easy manner. So here let us discuss the reactions which come in the same category, or reactions which involve the preparation of the same substance, or reactions which undergo the same substance undergo reactions. So here the first one type is reactions involving halide exchange in haloalkanes. Halide exchange in haloalkanes. So the first one is Finkelsten reaction. In Finkelsten reaction, so iodalkanes are obtained by treating chloro or bromoalkanes with sodium iodide in the presence of acetone. So here CH3Cl plus NaI in the presence of acetone. What is the formula of acetone? CH3 twice CO. Therefore we get CH3I plus NaCl. Similarly C2H5Br plus sodium iodide in the presence of acetone. In the presence of acetone we get C2H5I plus NaBr. So this is a Finkelsten reaction. Finkelsten reaction is that in which iodalkanes are obtained by treating chloro or bromoalkanes with sodium iodide in the presence of acetone. Now the next one is in this class SWARTS reaction. SWARTS reaction. In SWARTS reaction, fluoroalkanes are obtained by treating other halides with silver fluoride AgF, Hg2CF2, mercurous fluoride, COF3, cobalt fluoride, Sb fluoride, antimony fluoride. So here CH3Br plus AgF gives CH3F plus AgBr. So we get fluoromethane. Similarly C2H5Cl plus Hg2F2, mercurous fluoride. Therefore we get C2H5F. Here 2 chlorines, here this is 2 fluorines are there, therefore this is 2. Then we get Hg2Cl2. So in this way fluoroalkanes are obtained by treating other haloalkanes with silver fluoride, mercurous fluoride, cobalt fluoride, arsenic stibinum fluoride, that is antimony fluoride. So these two reactions, Finkelsten reaction and SWARTS reaction, are used to prepare iodalkanes and fluoroalkanes from other halides. Now named reactions involving preparation of aldehydes preparation of aldehydes. In this, number one is ROSENMUND'S reaction. ROSENMUND'S reaction. ROSENMUND'S reaction is that in which the acid chlorides are treated with hydrogen in the presence of palladium. Hydrogen in the presence of palladium, therefore we get aldehyde. So this is acid chloride COCl2 in the presence of H2 in the presence of palladium, and of course this is HgSO4. Here this is H2SO4. Barium in the presence of sulfuric acid acts as catalyst poison. Catalyst poison. See here, the activity of the catalyst, that is palladium, is decreased by using the barium in the presence of sulfuric acid. What happens if this is not used, if the catalyst poison is not used, the aldehyde so formed converts into acid. So the reaction proceeds to form acids. Therefore we get here this is CHO. So this ROSENMUND'S reaction is the best reaction for the preparation of aldehyde. If this catalyst poison is not used, the reaction goes up to acid. So ROSENMUND'S reaction. The next one is Stephen reaction. Stephen reaction. Stephen reaction. Here alkyl nitriles are treated with stannous chloride in the presence of HCl. So here RC triple bond N, alkyl nitrile in the presence of SnCl2 in the presence of HCl, and what do we get? We get RCH double bond N. This is known as imine. This is known as a imine. If nitrogen is connected, nitrogen is bonded with a carbon with a double bond, that is referred as imine, right? So this imine is hydrolyzed. Imine is hydrolyzed, therefore we get RCHO. Therefore this is Stephen reaction. So Stephen reaction is that in which alkyl nitriles are treated with stannous chloride in the presence of hydrochloric acid to get imine, and imine is hydrolyzed, we get aldehyde. Therefore we get an example, CH3C triple bond N. This is ethane nitrile plus SnCl2 plus HCl gives CH3CH double bond N. In the presence of water we get CH3CHO. So aldehyde we got. Next one is GATTERMANN reaction. GATTERMANN reaction. GATTERMANN reaction. What is GATTERMANN reaction? Benzene is treated with carbon monoxide. Benzene is treated with carbon monoxide in the presence of anhydrous aluminum chloride in the presence of CuCl. So benzene is treated with carbon monoxide in the presence of anhydrous aluminum chloride and CuCl. Therefore we get benzaldehyde. This is benzaldehyde. So all these reactions are used to get aldehyde, either alkyl aldehyde or aryl aldehyde. So ROSENMUND'S reaction, Stephen reaction, and GATTERMANN reaction. And another one is, one more reaction is there, that is ETARD reaction. ETARD reaction, ETARD reaction. This ETARD reaction, this is alkyl benzene. Alkyl benzene means maybe methyl benzene, that is toluene, ethyl benzene, etc. So alkyl benzene is treated with chromyl chloride, CrO2Cl2. This is chromyl chloride. We get an intermediate chromyl complex is formed. Therefore this is in the presence of CS2. So this is CHCrOH Cl2 taken twice. This is chromyl complex. So this chromyl complex is hydrolyzed acid hydrolysis, therefore we get the product benzaldehyde CHO. So in all these four reactions, that is ROSENMUND'S, Stephen, GATTERMANN and ETARD reactions, what happens, we are getting the final product is aldehyde, aryl aldehyde or alkyl aldehyde. Then the next type of reaction is reduction of carbonyl compounds. Reduction of carbonyl compounds. Carbonyl compounds means aldehydes or ketones. Aldehydes are ketones. So the first one is in this Wolff-Kishner reduction. Wolff-Kishner reduction. In Wolff-Kishner reduction, this is the carbonyl compound. This carbonyl compound is treated with hydrazine NH2NH2. NH2NH2. So let us write this NH2NH2 in this manner. This is H2N. NH2NH2. We get water is removed here. Therefore this O and this hydrogen is removed as water. Therefore we get C double bond N NH2. What is this substance? Hydrazone. Hydrazone. If hydrazine combines with carbonyl compound, the resulting substance is hydrazone. So this hydrazone is treated with KOH and ethylene glycol. KOH and ethylene glycol and heat. Therefore what do we get? This is CH2. This double bond nitrogen is removed and we get so here this is CH3. Now let us take an example. This is acetaldehyde plus hydrogen NH2. Therefore we get minus water. What do we get here? This is CH3 CH double bond NH2 acetaldehyde hydrazone. This acetaldehyde hydrazone is treated with KOH and ethylene glycol. Ethylene glycol means CH2OH, that is ethylene glycol. Therefore what happens, the double bonded carbon atom is reduced to alkane. Therefore this is we get CH3H2. This is nothing but ethane. So this is Wolff-Kishner reduction. Let us take one more example with ketone. Here we took aldehyde, now we take ketone. So this is CH3 CH3. What is this substance? Acetone plus hydrazine. Therefore what do we get? Ketone, acetone, hydrazone. CH3 C double bond NH2. So this in the presence of KOH and ethylene glycol. What do we get? CH3 CH2CH3. So this is nothing but propane. Thus in Wolff-Kishner reduction, what happens? The carbonyl compounds are reduced to respective alkanes. This is propane. So this is the reduction of carbonyl compounds. In reduction of carbonyl compounds, two different reactions are there. One is Wolff-Kishner reduction and another one is, now let us discuss the CLEMENSE'Ns reduction. See here, in this way, you have to classify the reactions into different categories in which the product may be same or the reactant may be same, etc. Now let us see the CLEMENSE'Ns reduction. In CLEMENSE'Ns reduction, this is carbonyl group. In CLEMENSE'Ns reduction, amalgam. Let us take zinc amalgam. Amalgam means an alloy of mercury and some other metal, that is amalgam. So if you take a zinc amalgam, in the presence of HCl, we get CH2. So now let us take some examples, say CH3 C hydrogen plus zinc amalgam, or in the presence of zinc amalgam, of course HCl, we get CH3 CH. This is H2. What is this? Ethane. Similarly, acetone CH3C CH3. This is CH3. double bond O in the presence of zinc amalgam and HCl, we get CH3, CH3, and of course this is hydrogen, this is propane. So what we discussed here, reduction of carbonyl compounds. There are two different reactions are there. One is Wolff-Kishner reduction and CLEMENSEN'S reduction. In both of these reductions, only the difference is reagent. In Wolff-Kishner reduction, the reagent is hydrazine, whereas in CLEMENSEN'S reduction, the reagent is amalgam plus HCl. So in this way, what happens if we study the named reactions in a particular manner, then we can remember the named reactions in an easy manner, and of course you score the good marks in board examination. Now let us see another reaction, that is Friedal-Crafts reaction. Friedal-Crafts reaction. In Friedal-Crafts reaction, alkyl group, acetyl group, benzoyl group can be introduced on the benzene ring. That is, the Friedal-Crafts reaction means introduction of RCOCl or C6H5 group is called on benzene ring. On benzene ring is called Friedal-Crafts reaction. Friedal-Crafts reaction. Friedal-Crafts reaction. So what is the reaction? Here this is a benzene ring plus CH3Cl methyl chloride in the presence of anhydrous aluminum chloride. Anhydrous aluminum chloride acts as a Lewis acid. That Lewis acid, and of course it creates the electrophile. Therefore, what do we get here? This is CH3. What is this substance? Toluene or methyl benzene. So benzene reacts with the methyl chloride or alkyl chloride in the presence of anhydrous aluminum chloride. We get alkyl benzene. Here anhydrous aluminum chloride is the electrophile felicitator. It acts as Lewis acid. In the same manner, this is known as Friedal-Crafts alkylation. Alkylation means because alkyl group is introduced. Right. Now here let us take one more. This is benzene ring plus this is CH3COCl, acetyl chloride in the presence of anhydrous aluminum chloride. Anhydrous. So here anhydrous, this is CH3CO. So what do we get here? This is benzene C double bond O CH3. This is acetyl group. Since acetyl group is introduced, this is referred as Friedal-Crafts acylation. Friedal-Crafts acylation. Right. So Friedal-Crafts reaction is that in which the groups like alkyl, acyl or benzoyl groups are introduced on the benzene ring in the presence of anhydrous aluminum chloride, and of course the reaction is referred as a Friedal-Crafts reaction. Now let us see one more reaction in this Friedal-Crafts, that is introduction of benzene ring. Introduction of benzene ring. So this is benzene ring plus C double bond O Cl. What is this substance? Benzoyl chloride. This is known as, this substance is benzoyl chloride. So here in the presence of anhydrous aluminum chloride, anhydrous. So what happens here? Hydrogen, and of course this chlorine is removed. Therefore we get so what is this substance? benzophenone. Benzophenone. Previously we got this substance, no, in the second one. We got after acylation we got in this manner. This is, what is the name of this substance? The name of this substance is acetophenone. Acetophenone. This is benzophenone. So in this way, in a Friedal-Crafts reaction, we can introduce alkyl group, acyl group, benzoyl group on the benzene ring in the presence of anhydrous aluminum chloride. Therefore, such reaction is a Friedal-Crafts reaction. Now let us see the reactions involving alpha hydrogen. Reactions involving alpha hydrogen. CH3, CH2, C double bond O, single bond H. This is carbonyl carbon. The carbon adjacent to carbonyl carbon is alpha, and of course this is beta. The hydrogens present on this carbon are referred as alpha hydrogens. Alpha hydrogens. So aldehydes and ketones having at least one alpha hydrogen, they undergo condensation in the presence of dilute alkali, and we get beta hydroxyaldehyde or ketone. And of course this reaction is known as aldol condensation. Aldol condensation. This aldol condensation I discussed in one video thoroughly, the different varieties with different examples. Anyhow, let us see once again. So this is CH3, C double bond O, single bond H, plus H, this is CH2. So for this molecule I am taking alpha hydrogen here, this is CHO. So this bond shifts here, therefore this hydrogen comes and attacks here, and of course this bond comes and attacks here. Therefore we get, this is in the presence of dilute sodium hydroxide. Therefore what do we get? This is CH3C, this is OH hydrogen, this is CHO. So here this is carbonyl carbon, this is alpha carbon, this is beta carbon. Therefore this is referred as beta hydroxyaldehyde. This beta hydroxyaldehyde in the presence of concentrated sulfuric acid. If we treat it with in the presence of concentrated sulfuric acid, this OH and H, they are removed as water. That means dehydration takes place. Dehydration takes place. Therefore, if dehydration takes place, what will happen? This becomes CH3, CH double bond CH, CHO. This is alpha beta unsaturated. This is alpha carbon, this is beta carbon. In between alpha and beta, unsaturation is there. Therefore, this is alpha beta unsaturated aldehyde. Unsaturated aldehyde. So this is aldol condensation. So this aldol condensation for aldehyde. Similarly, we can write even for ketone also. So this is C double bond O, CH3, CH3. This is acetone. Acetone. Another acetone molecule, CH2, C double bond O, CH3. This is another acetone molecule. This is alpha hydrogen. This bond shifts here. Therefore, this hydrogen attacks here. This comes and attacks on this. Therefore, this is in the presence of dilute alkali, that is NaOH. So, what do we get here? This is CH3, COH, CH3. This is CH, C double bond O, single bond CH3. So what is this substance? This is ketone is the main functional group. 1, 2, 3. The 1, 2, 3, 4, 5. This is pentane. So this is pentan 2-one. Pentan 2-one. On pentan 2-one, methyl group is there and hydroxy group is there. Therefore, this is 2-hydroxy, 2-methyl, 2-hydroxy, 2-methyl, pentan 2-one. And of course, this is a beta hydroxyaldehyde. Beta hydroxyaldehyde. Beta hydroxyaldehyde. So this in the presence of a concentrated sulfuric acid H2SO4. What do we get? This water is removed, dehydration takes place, therefore we get CH3, CH3, double bond CH, C double bond O, CH3. So what is this substance? This substance is, this is pent, methyl group is present on 4th carbon atom. So here methyl hydroxy group is present on 4th carbon, hydroxy group is present, methyl group is present on 4. Therefore this is 4 hydroxy, 4 methyl, pent and 2 one. Therefore this is 4 methyl, pent, double bond is present on 3rd carbon, pent, 2 in, 2 on. So this is the alpha beta unsaturated ketone. There is one more reaction. If alpha hydrogen is not present, then such a reaction is a CANNIZZARO reaction. CANNIZZARO reaction. Aldehydes having no alpha hydrogen. Aldehydes having no alpha hydrogen undergo condensation. Undergo condensation to form one molecule of alcohol, and one molecule of acid salt. So here what happens? One molecule undergo reduction, one molecule undergo oxidation. The molecule which undergoes reduction becomes alcohol, the molecule which undergoes oxidation becomes acid salt. Therefore this reaction is disproportionation reaction. Disproportionation reaction means a reaction in which the same substance undergo oxidation as well as reduction is known as a disproportionation reaction. For example, this is HC double bond HOH. This is methanaldehyde, methanal, or formaldehyde, methanal, plus another molecule HC double bond O single bond H. So this is aldehydes having no alpha hydrogen undergo this is not condensation, undergo disproportionation to form, right. So this is the presence of concentrated alkali. So in the concentrated alkali, what do we get? One is alcohol CH3OH plus HCOONA. This is acid salt, this is alcohol, methyl alcohol and sodium formate. If we take another molecule, that is say benzaldehyde, C double bond O single bond H. See, in this formaldehyde, this is the carbonyl carbon. On either side of this carbonyl carbon there is no carbon. That means alpha carbon is not present. If alpha carbon is not present, alpha hydrogen is also not present. So for this carbon also, this is carbonyl carbon, right? This is hydrogen and of course this is carbon, but there is no hydrogen. So here also alpha hydrogen is not present. Plus one more, therefore we get C double bond O single bond H in the presence of concentrated alkali. What do we get here? This is CH2OH, benzyl alcohol. This is benzyl alcohol. This is, and of course acid salt, COONA, sodium benzoate. This is benzyl alcohol, sodium benzoate. So this is a CANNIZZARO reaction.